For those who would journey across the vast reaches of interplanetary space, the solar system offers many breathtaking sights. But nothing quite compares to this. A giant world made of gas, completely encircled by a perfect gleaming set of rings. Like a cosmic illusion conjured out of the infinite expanse of space, Saturn delights the eye and challenges the imagination. Yet Saturn is no illusion. It is an exotic natural laboratory that can help shed light on how planets form and perhaps on how life evolved.
4, 3, engine start. 1, 0, liftoff.
In July 2004, after traveling in space for nearly 7 years, NASA's Cassini mission arrived at Saturn, marking the start of a bold new chapter in solar system exploration. Cassini is not the first spacecraft to reach Saturn, but it is the first to remain in orbit around the planet. It is also the most expensive and ambitious planetary probe in history, gathering data and images over a long period that have completely revolutionized our understanding of Saturn and its many unique features. From its swirling, dynamic atmosphere, to its dozens of exotic and mysterious moons, to the trillions of floating bits of ice and dust that together make up Saturn's intricate system of rings. And with so much to explore, Cassini would need all the time it could get. When Cassini was launched, scientists hoped that their spacecraft would survive for 4 years. In fact, Cassini has more than doubled that. And after 8 years and counting, it's beginning to reveal details that a shorter mission would have missed. Details that will ultimately help scientists solve some of Saturn's most baffling mysteries. It's easy to understand why the extra time has been so important for Cassini. Just consider how profoundly things can change on our own planet, simply by watching the yearly cycle of the seasons. Without taking a single step, the journey from winter to summer is like a trip to a whole new world. Like Earth, Saturn is also a planet of seasons. The difference is that because Saturn is so far from the Sun and its orbit so large, a year on Saturn takes nearly 30 years on Earth. When Cassini first arrived at Saturn, the planet's southern hemisphere was in the midst of late summer. The South Pole was tilted toward the Sun, giving Cassini's cameras a superb view of the planet and its rings from below. But over the next several years, as Saturn proceeded along its orbital path, southern summer gave way to northern spring. As the seasons changed, so too did the angle of the Sun, and Cassini's cameras faithfully recorded a fascinating transformation. Month by month, the North Pole slowly emerged from darkness, while the broad shadows of Saturn's multiple rings gradually narrowed and shifted. By August of 2009, Saturn was at equinox, and for the first time in 15 years, sunlight was shining directly onto the planet's equator. At equinox, the sun illuminates the rings from the side so that their shadows on the planet below converge into a single pencil-thin line, dividing Saturn evenly in half. While across the vast ring plane, a host of rare and striking visual effects appear. Here, a narrow opening in the rings seems to be the work of a cosmic scalpel, but appearances are deceiving. What seems to be a cut in the rings is simply the shadow of Saturn's moon, Mimas, stretched out across the ring plane. Such tricks between light and dark, rings and moons, can only be observed near the time of the equinox, and they are fleeting. Here, Cassini tracks the shadow of a different moon, Tethys, sweeping over the rings in a matter of minutes. Looking more closely, the same effect allows Cassini to spot something new, a tiny moonlet just 300 meters across, embedded within the rings. Such objects are normally invisible, but during Saturn's equinox, their presence is revealed by the shadows they cast. Here, a jagged line of shadows reveals not just a single moon, but what appears to be an entire mountain range towering 2.5 kilometers above the ring plane. These peaks may be more like clouds than mountains. Puffs of dust-sized particles deflected upward by larger chunks of icy material orbiting within the thickest and brightest portion of Saturn's rings. Meanwhile, as the sun begins to warm the planet's northern hemisphere, there is more for Cassini to discover. Not just in the rings, but in the hazy depths of Saturn's atmosphere, where a dramatic change in the weather is about to unfold. For the planet Saturn, 1.5 billion kilometers from the sun, the concept of summer is a relative term. Here, at the outer reaches of the solar system, the sun is just 1% as bright as we experience it on Earth. That's far too weak a light for solar panels to be of any use. So the Cassini mission to Saturn relies on the decay of nuclear isotopes to power its cameras and electrical systems. Yet as the seasons change on Saturn, there are signs that the sun can still have a profound effect on this majestic planet. By late 2009, Cassini had been in orbit around Saturn for over 6 years. It had witnessed Saturn's spring equinox and was watching closely as summer approached for the planet's northern hemisphere. The change brought more light and more heat to the northern half of Saturn's hazy, cream-colored atmosphere. Saturn's clouds are over 100 kilometers thick. Their tops are made of frozen ammonia ice, but far below there is a layer of water vapor. And as heat generates turbulence in these clouds, the result is lightning. In November of 2009, Cassini's cameras, for the first time, witnessed an electrical storm rattling the night side of Saturn. And just like on Earth, the bright flashes of electrical energy came with bursts of radio static. Clearly, the changing seasons had awakened something in Saturn's atmosphere. 1 year later, on December 5th, 2010, Cassini snapped this image of Saturn on the same day the spacecraft's radio and plasma experiments detected lightning in the atmosphere. Although no one realized it at the time, this image contains the first hint of a giant storm about to erupt in Saturn's atmosphere. In this first image, the storm appears as a tiny spot relative to the planet, even though it is already 2,000 kilometers across and growing fast. Within 3 weeks, the spot had evolved into a vast and complex storm system with towering clouds of white ammonia crystals. For months, the great storm raged on, becoming one of the largest disturbances ever seen on Saturn. Over the course of 2011, Cassini's electronic eyes revealed the storm's progress in unprecedented detail, using its infrared vision to peer further into the planet's unsettled atmosphere. False color views like these helped reveal the storm's structure. Here, red indicates the deepest levels exposed by the storm's churnings. Eventually, the storm wrapped itself all the way around the planet, forming a continuous band of chaotic turbulence. For an entire year, it had given scientists their best chance ever to witness the complex workings of Saturn's atmosphere in action.
Scientists still have a lot to learn about how Saturn changes with the seasons. And those changes don't just apply to Saturn's atmosphere, but to its largest moon, Titan, one of the most intriguing destinations in the solar system.
Titan is more than a moon. It is like a planet unto itself, with a dense atmosphere made of nitrogen gas and a thick orange-colored haze layer that acts like a natural smog. Although the smog conceals Titan's surface from view, it only serves to raise scientists' excitement about what kind of world may lie underneath. Even before spacecraft were sent to Saturn, astronomers realized that conditions on Titan's surface were bound to be interesting, because temperatures and pressures there allow methane to exist as a liquid, a solid, and a gas. Could Titan have rivers and lakes of liquid methane? That is the question scientists hope to finally answer with Cassini. In October 2004, 3 months after arriving at Saturn, Cassini was scheduled to make its first close pass of Titan, and expectations were running high. The results were astonishing. Through its infrared eye, Cassini could see that the surface of Titan was far more interesting than anyone had expected, with a sharp separation between light and dark regions that strongly resembled coastlines on Earth. Meanwhile, Cassini's radar unveiled a surprisingly diverse surface that suggested a complex geologic history. But where were the lakes and rivers of methane? Cassini couldn't tell. Because there are no shadows under the foggy haze of Titan, there's no way for the infrared camera to reveal whether the light or dark areas were of different elevations. However, in close-ups, all of the areas seem to be windswept, suggesting that both the light and dark areas seen here are just different kinds of dry land. Fortunately, Cassini had one more tool to help make sense of what it was seeing on Titan. The Huygens probe, built by the European Space Agency, had come to Saturn attached to Cassini. In January of 2005, Huygens released itself from the main spacecraft and plunged into Titan's enveloping haze. There, its cameras radioed back an important discovery, an aerial view showing some dark, branching channels that had clearly once been carved out of Titan's surface by some kind of flowing liquid. Amazingly, Huygens even continued operating after it hit the surface. Its final image was a tantalizing view of an alien terrain, littered with what looked like rocks, rounded by the action of a flowing liquid. Scientists knew the rocks had to be chunks of water ice, which at the extremely cold temperatures on Titan's surface behave like solid rock. But where was the liquid that had flowed over them and carved the channels? To understand what they had found, Cassini's scientists would need a change of season. When NASA's Cassini spacecraft journeyed to Saturn, the planet's giant moon, Titan, had the largest unexplored surface in the solar system. And when Cassini's infrared camera finally peered through Titan's impenetrable clouds, scientists found a world strangely divided into territories of light and dark. The light areas were easy to explain. Like Saturn's other moons, Titan's surface is mostly made of ice. But the dark regions that ran along the giant moon's equator were a puzzle. Was this the liquid methane that scientists had expected to find flowing over Titan's frozen surface? The answer proved to be more complicated. Although these dark plains may have been flooded by liquid in the past, what Cassini found looked more like dry land. Using its radar system to bounce signals off of Titan's surface, Cassini revealed row upon row of wind-blown dunes. The dunes reveal that Titan's dark equatorial zone is more of a desert than a sea. So to look for signs of liquid on the moon's icy surface, Cassini turned its attention to Titan's poles. It was here that Cassini saw its first obvious signs of weather on Titan, in the form of thick white clouds of methane circling around the South Pole. In time, Cassini would see many more methane clouds on Titan. As the season changed and sunlight shifted northward, they began appearing over Titan's equator and the North Pole. The clouds proved that Titan was a dynamic world with a restless atmosphere. But did Titan's shifting patterns of clouds also mean rain? On Earth, rain is the way that evaporated water returns to the surface, forming rivers and lakes. On Titan, conditions should be just right for methane to behave in the same way. The first clue that this is happening was this large dark spot found near Titan's South Pole. Unlike the dark regions near the equator, this one had no dunes, but sharp boundaries and a shape and size that reminded scientists of one of Earth's Great Lakes. They called it Ontario Lacus. The more Cassini peered at Ontario Lacus, the more this strange dark feature seemed like a liquid body. By taking advantage of the spacecraft's radar views from different angles, scientists were even able to construct a computer-animated flyover. There are beaches here, formed by the action of moving waves. There are inlets and bays where liquid has flooded in. And there are even river deltas where dark channels appear to flow into the lake. There seems little doubt that Cassini had at last found a body of liquid methane on Titan. Now Cassini turned its attention northward, beyond the dark dune fields near the equator, and up into regions still emerging from Titan's cold, dark northern winter. What Cassini discovered there looked very much like a landscape inundated with lakes. In radar images, they stand out like pools of black ink against a ghostly white icescape. And then something much larger. Hints of a vast and jagged coastline with jutting peninsulas and great islands. It was to be Cassini's first close-up glimpse of Titan's largest liquid feature. This is Mare Kraken, the Kraken Sea, named after a legendary sea monster. As large as the Caspian Sea on Earth, Mare Kraken spreads across so much of Titan's northern landscape that its full extent has yet to be mapped. The more data Cassini gathered, the more obvious it became that it's the northern half of Titan where fluid is most concentrated. And in case anyone needed more convincing, on December 17, 2009, Cassini spotted something that scientists had long been hoping to see. It is the glint of sunlight reflecting off the mirror-like surface of the Kraken Sea. This telltale flash is the final piece of evidence that Titan truly is a world of lakes, the only world in our solar system, apart from Earth, where liquids exist naturally on the surface.
In one sense, Titan presents us with an utterly alien landscape, where water behaves like solid rock and methane gas behaves like water. But because there's an atmosphere on Titan, with wind and rain, lakes and rivers, something about this alien landscape also reminds us of home. It's not Earth as we know it, but it shows us where our own planet fits into the larger family of possible worlds, all shaped by the same phenomena.
Scientists are now considering future missions to Titan that could include dropping a boat onto one of its lakes, or perhaps the Kraken Sea. Such a spacecraft would become the first mariner to sail beyond the seas of our own planet and reveal the unknown wonders that lie await on these distant shores. When that day comes, it will not only teach us more about Titan, but confirm what the Cassini mission has shown us over and over again. That while seasons may change on Saturn, our capacity to be enchanted by this remarkable planet and its moons endures without end. To explore even the nearest worlds of our solar system, a spacecraft must journey across hundreds of millions of kilometers of interplanetary space. But in the process of doing so, it may also reach back across billions of years of cosmic history. On Earth, tracing that history presents an enormous challenge. The ceaseless movements of water, ice, wind, and volcanic eruptions, as well as the actions of a diverse and complex array of living organisms, all combine to create a planet that is never at rest. Our world is a world of the present, a world of change. To access our past, we must leave Earth behind and find those places that time has left untouched. On September 17, 2007, a NASA spacecraft began the most ambitious journey yet back through the 4.5 billion years of our solar system's history. Its goal? To open a window into a distant era, when the planets as we know them today were still just forming. Fittingly, it's called the Dawn mission. While the secrets of the solar system's early history remain elusive, the place to hunt for those secrets is not. It is the asteroid belt, a zone of flying rocks and miniature worlds that forms a vast ring of material orbiting around the sun. The asteroid belt is a place of transition between the inner solar system, where small rocky planets like Earth are found, and the outer solar system, where the planets are massive spheres of liquid gas. And it's here that scientists are seeking insights into a different transition, the one that billions of years ago led from small bits of cosmic dust and debris to the planets that populate our solar system today, including at least one such planet, our own, that is capable of supporting life.
There are hundreds of thousands of objects in the asteroid belt. Most are only a few kilometers in size, tiny flying mountains that tumble namelessly through space. But a handful of asteroids are hundreds of times larger than that and much more interesting. In fact, they are just large enough to reveal the first steps on the way to making true planets.
Dawn's mission is to explore the two most massive asteroids, Ceres and Vesta. Both were discovered more than 2 centuries ago, even before astronomers realized there was such a thing as an asteroid belt. Now they are believed to be relics from a far more distant past, when objects that were several hundred kilometers in size became the building blocks of the solar system's rocky inner planets. The asteroid belt is the place where such objects can still be found. But even here, they are rare. Most of them were broken apart by collisions with other asteroids long ago. As the largest survivors of this celestial shooting gallery, Ceres and Vesta are especially important to scientists. But until now, the best views we've had show them as little more than blurry, uneven blobs. Here, the Hubble Space Telescope has taken enough images of Vesta to show the asteroid rotating on its axis. But there is only so much that can be learned from this distance. So, with a sophisticated suite of instruments and a long list of questions, the Dawn mission set out for the asteroid belt, with Vesta as its first stop. Once free of Earth's gravity, Dawn spread its 2 enormous solar panels, giving the spacecraft the appearance of a great bird in flight. The panels are part of an innovative propulsion system that generates electricity from sunlight and uses it to drive a high-speed stream of ionized xenon. This method has proved ideal for pushing Dawn along its complicated flight path, which took it past Mars in 2009 and onward into the main asteroid belt. But this is not the first time spacecraft have explored this rocky region of the solar system. In 1991, the Galileo mission on its way to Jupiter passed near enough to the small asteroid Gaspra to return this image, the first ever asteroid close-up. 2 years later, Galileo passed a much larger asteroid named Ida and discovered that it was circled by a tiny moonlet which scientists dubbed Dactyl. In 1997, the Near-Shoemaker spacecraft saw a very different looking kind of object when it passed near the asteroid Matilda. And finally, in 2010, Europe's Rosetta mission captured this view of Lutetia. At over 100 kilometers across, it was the largest asteroid yet to be revealed. Yet all of these views, taken by spacecraft on their way to other destinations, are tantalizingly brief. This time, scientists were planning for a very different kind of encounter, one that would allow them for the first time to orbit and survey in detail the 2 giants of the asteroid belt. By July of 2011, that encounter was set to begin. After 4 long years, Dawn was finally approaching its first stop, Vesta. As Dawn's cameras zoomed in on their target, scientists prepared to open a new chapter in asteroid exploration. They would not be disappointed. 350 million kilometers from the Sun, the battered surface of the asteroid Vesta bears witness to the solar system's violent beginnings. This is the view from the Dawn mission, the first spacecraft to closely examine Vesta in an effort to tease out some billion-year-old secrets about the formation of the planets. Although it is one of the largest asteroids of all, Vesta is tiny compared to Earth, with a surface gravity that is only 2% what we experience on our world. Yet even such a tiny gravitational pull is enough to keep Dawn in orbit around Vesta. And soon after it arrived, in July of 2011, the spacecraft set about imaging the asteroid's entire surface end to end. Like other asteroids, Dawn has found that Vesta is riddled with craters. Each crater marks the spot where another smaller object has pounded Vesta's surface at high speed. Some craters are more recent than others, with clear, sharp edges. This group of 3 craters, imaged shortly after Dawn arrived at Vesta, is nicknamed the Snowman. Other features are more mysterious. As Dawn first approached Vesta, one of its first discoveries was a set of deep parallel troughs running roughly along the asteroid's equator. Although these troughs are not craters, Dawn scientists would eventually realize that they too are related to the large-scale collisions that have rocked Vesta in the distant past.
The fate of an asteroid is determined by its encounters with others. In the early days of the solar system, asteroids such as Vesta were built up from smaller bodies that collided and stuck together.
Many of these early clumps continue to grow and combine, forming full-sized planets like Earth. But in the location that is today known as the asteroid belt, it's thought that the strong gravitational influence of Jupiter, the solar system's largest planet, scattered the asteroids and kept them from forming something larger. Instead, many were broken apart by collisions, with fragments still occasionally raining down on Vesta right up to the present time. What makes Vesta an exception is that it has survived at its current size. Relative to most other asteroids, Vesta is a giant. And while it may look like an asteroid on the outside, there is evidence that Vesta could have a planet-sized heart. Most asteroids are thought to be the same inside and out. They have been built up bit by bit out of the dust and debris that swirled around the Sun when the solar system formed over 4.5 billion years ago. Dark and primitive, they are rich in carbon, oxygen, and other elements that are common throughout the Milky Way, the byproducts of the life cycles of the stars. Vesta is known to be very different. By analyzing the sunlight that reflects off its ash-gray surface, scientists have found it is more like basaltic rocks found on Earth. Such rocks are created in the heat of volcanic activity, created when lava cools on or near Earth's surface. There are also meteorites with a similar composition. Space rocks, thought to be pieces of Vesta, which were blasted off the asteroid and later tumbled to Earth. These precious fragments suggest that Vesta was a molten body in the distant past. But how could such a small, cold world have produced lava? The answer lies with the star. A supernova is the sudden death of a massive star and one of the most violent events in the universe. For a brief moment, a supernova can outshine all the billions of stars in a galaxy combined. As the explosion rips the star to shreds, matter that has been highly energized by the supernova flies off in all directions. Of the many kinds of atoms that are created in a supernova, one of the most important to astronomers is aluminum-26, a radioactive isotope that decays over hundreds of thousands of years. Because aluminum-26 is known to have been present as our solar system was forming, scientists now believe a high concentration of this material is what gave Vesta its original heat billions of years ago. But today, as dawn patrols Vesta's pockmarked surface, there seems to be no obvious traces of past volcanic activity. In a search for subtler clues, Dawn has paid close attention to the deepest part of Vesta's surface, near the asteroid's south pole. Even before Dawn arrived, scientists knew there was a dark feature here, which they quickly realized was the shadowed hollow of a giant impact crater. Scientists have named the crater Rhea Silvia. This computer-generated perspective, based on dawn imagery, shows what it would be like to swoop down on Rhea Silvia and fly around its outer perimeter. By adding false color, where red represents high elevation and blue the lowest areas, it's possible to see the structure of this enormous crater more clearly. Rhea Silvia is, without a doubt, the largest and most impressive feature on Vesta. Nearly 500 kilometers across and 19 kilometers deep, it has a central mound that is more than double the height of Mount Everest. And as Dawn moved in for a closer look, it was soon clear that the giant crater was just as impressive in its details. Here, jagged cliffs protrude from the wall of Rhea Silvia, revealing the bedrock that lies beneath a thick blanket of impact debris. Further down, smaller impact craters with scattered boulders gouged out of Rhea Silvia's low-lying floor offer the most revealing glimpse at a part of Vesta that was once deep below the surface. Armed with these and other unprecedented views, scientists would soon discover that Rhea Silvia was the key that would help them unlock the 4.5 billion-year-old history of Vesta. But along the way, that key would also provide an unexpected turn. By April of 2012, NASA's Dawn spacecraft had brought itself to within 200 kilometers of the asteroid Vesta, much closer than the International Space Station orbits Earth. At such close quarters, Vesta's airless surface appears peppered with small craters, many of them produced when chunks of rock that were blasted off Vesta came crashing back into the asteroid. With Dawn's help, astronomers have now confirmed that the biggest blast of all came roughly 1 billion years ago, when a smaller asteroid collided with Vesta and formed its giant crater, Rhea Silvia. Now it appears that many of Vesta's unique features are tied to this ancient impact. But when Dawn began looking at Vesta's giant crater up close, it encountered another surprise. Rhea Silvia sits on top of another crater whose outline can still be seen. Nearly as large, but 1 billion years older, scientists have dubbed Vesta's second giant crater Venenia. So now it's clear that Vesta was twice hammered by a mighty blow. Each one raised its own set of ridges and troughs, and each one excavated tons of debris that were then scattered across much of Vesta's ancient surface. But while some of Vesta's past now lies buried by these giant impacts, there are pieces of it that can be examined up close. That's because the same two impacts that carved out Vesta's largest craters also shattered its crust and mantle, blasting enough rock into space to create an entire family of smaller asteroids. It is these pieces, known as vestoids, which have occasionally found their way to Earth as meteorites, bringing us valuable clues about the nature and history of Vesta. Now those clues can be directly compared with the data that Dawn has gathered by orbiting Vesta up close. The results make clear that Vesta is a unique fossil from the solar system's deep past. At that time, its liquid interior divided into a metallic core and a rocky mantle, with minerals that become more iron-rich the deeper you go. In this way, scientists have found that Vesta is less of an asteroid and more of a miniature planet, an early result of the same process that would eventually lead to the formation of Earth in all its geologic diversity.
Dawn's one-year encounter with Vesta has given us a close-up view and a new understanding of the solar system's ultimate survivor. But our explorations of the asteroids and the asteroid belt are just beginning.
In the summer of 2012, Dawn's ion engine powered up and gently pushed the spacecraft out of its orbit around Vesta, putting it on course to rendezvous with the asteroid Ceres in 2015. And while Dawn moves on, scientists are also imagining even more ambitious explorations of asteroids that are closer to home. They are eyeing the so-called near-Earth asteroids, which have drifted far from the main asteroid belt and over millions of years have wandered into our own part of the solar system. The nearest of these wandering neighbors is the asteroid Eros, an irregular chunk of flying rock nearly 35 kilometers long. This was the target of the Near Shoemaker mission, which orbited Eros in 2000 and even managed to touch down on the asteroid's boulder-strewn surface a year later. By 2019, NASA's OSIRIS-REx mission hopes to follow a similar strategy, closing in on near-Earth asteroids and capturing up to 2 ounces of material for return to Earth. Such missions hold great value for researchers trying to piece together the detailed composition and history of these nearest asteroids, and there are good reasons for doing so. Evidence suggests that in the past, asteroids colliding with Earth played a fateful role in shaping the history of life on our planet. In the future, near-Earth asteroids may become important in a different way, as a tantalizing opportunity for those seeking to harness these objects for their mineral wealth. Such a future will mean that the asteroids, which were long overlooked in the early years of space exploration, could one day become our main reason for venturing into space, and the next frontier in humanity's epic quest to reach for the stars. water. It is Earth's defining feature. Other planets besides our own have towering mountains and vast deserts. But only on Earth do we find this: entire oceans of water in liquid form covering much of the planet's surface. Water shapes our world. It dissolves rock, moves energy around the globe, and helps make our climate livable. But most important of all, water lets chemicals mingle, including those chemicals that are crucial for sustaining life. Quite simply, without water, life as we know it would not exist.
Water is so important to life on Earth that finding it has become a key goal for scientists looking for life elsewhere in the solar system and beyond. In effect, we have become cosmic dowsers, feeling around for hints that even now, water is flowing somewhere out there.
The quest for water has led us to the places that at first glance seem to resemble Earth the most. Torrid Venus and desolate Mars. But surprisingly, the strongest evidence we have that water is present in liquid form elsewhere in our solar system comes from a world that is utterly different from our own. This is Enceladus, a tiny frozen moon of Saturn located 1.5 billion kilometers from the Sun. Although it is just one of dozens of moons orbiting Saturn, scientists have long suspected that there is something special about Enceladus. For starters, it has the brightest surface in the entire solar system. And another curious detail, Enceladus travels around Saturn embedded within a faint and diffuse band of particles known as Saturn's E-ring. Astronomers have long suspected that the E-ring is related somehow to Enceladus. But how? The question would be answered in 2005, when NASA's Cassini spacecraft began the first of several close passes of Enceladus during its ongoing exploration of the Saturn system. In some areas, the surface is clearly ancient, marked by craters that have accumulated over billions of years. But toward the south pole of Enceladus, the surface features tell a very different story. Here, the landscape is dominated by a strange pattern of linear grooves. In July 2005, Cassini was swooping in for a closer look at this area when it spotted a dramatic series of 4 deep fissures. Scientists nicknamed the strange markings the tiger stripes. During the same flyby, one of Cassini's instruments detected signs of a gaseous material above the moon's south pole. The gas was mainly water vapor. These clues made it clear that something truly unique is happening on Enceladus. So when Cassini next encountered the moon in November of 2005, mission controllers commanded the robotic probe to swivel around and capture an image of Enceladus backlit by the sun. The result was this incredible image showing jets of water vapor spewing from the south polar region of Enceladus. These jets must be the sources of the E-ring that surrounds Saturn, and they are among the most exciting revelations of the entire Cassini mission. Captured in the sun's glare, the jets look like geysers of icy mist. Enceladus, once expected to be a cold and dead moon, seems to have a warm and geologically active interior, and the results can be seen literally spilling through the cracks. But where is the heat coming from? Enceladus is too far from the sun to be warmed by its rays. Yet it is also too small to be able to hold on to the internal heat it acquired when it formed billions of years ago. Instead, scientists suspect that somehow Enceladus is gaining additional heat from the gravitational pull of Saturn. But whatever is heating the moon, evidence is mounting that it's been going on for a long time. For example, Cassini has revealed that a blanket of snow made up of icy particles from the geysers is building up on the moon's surface. In some areas, the blanket is 100 meters thick, an amount that scientists estimate would take 10 million years to accumulate. If Enceladus has been active for that long, it may be because beneath its icy surface lies an entire ocean of liquid water. If this is true, then the geysers of Enceladus represent the most direct evidence yet for liquid water beyond Earth. And where there is water, there could be life. But water is a dynamic substance that brings change wherever it turns up. That's why looking for change may ultimately be the best way to find water beyond Earth. In our solar system, no other planet has intrigued, excited, and misled astronomers more than Mars. Mars is the only planet with a solid surface that can be observed easily from Earth. And for generations, its rust-colored glow has beckoned would-be explorers. First with telescopes, and then with wave after wave of robot probes. What they have discovered is a world of dry rivers and ancient lake beds. A world where water flowed freely billions of years ago, forming mineral deposits and bubbling through the soil in hot springs. And it is also a world where water still exists, in frozen form, locked as permafrost in the Martian soil. But in all this exploring, is it possible we've missed the most important discovery of all?
Mars is a remarkable world with a complex history in which water once played an important role. Today, spacecraft are orbiting around Mars and roving over its surface in an effort to piece that history together. But in the process, they are also turning up some unexpected clues that suggest there may be liquid water lurking on Mars today, and we can find it if we know where to look.
Mars has received so much attention over the years, it may seem strange that only now are scientists beginning to spot these clues. But that is because for many decades, the exploration of Mars was a fleeting affair, with visiting spacecraft only surviving for a limited period of time. That changed starting in September of 1997, when Mars Global Surveyor arrived. It was the first of a new generation of orbiters that have had Mars under continuous surveillance ever since. And that is precisely what is needed to look for small-scale changes that could be a sign of water flowing near the Martian surface. At face value, such an idea seems misguided. After all, Mars is a freeze-dried world with an atmospheric pressure so low it's nearly a vacuum. Under such conditions, any liquid water on the surface would rapidly vaporize. But in June of 2000, scientists operating the camera on board Mars Global Surveyor reported an exciting find. In some of the tens of thousands of images, they found small gullies carved into the sides of canyons and crater walls. The gullies looked suspiciously like they were formed by water that seeped from the rock and flowed downhill before evaporating. And unlike those features formed where water flowed on Mars billions of years ago, the gullies looked recent, as if they were just formed. When they were first discovered, some scientists speculated that the gullies might be a sign that there are hidden reservoirs of underground water on Mars that occasionally spill onto the surface. It's a tantalizing possibility, one that became even more exciting when some of the gullies appeared to be changing from one year to the next. Perhaps water was responsible. But there was a catch. The gullies were typically found far from the equator, in craters or canyon walls that faced away from the sun. These cold and shaded places should be the least likely to yield liquid water. And that suggested another way to explain the gullies. Mars is so cold that during the winter months, the carbon dioxide in its thin atmosphere can settle onto the surface as frost. Such a buildup of CO2 could trigger landslides simply by adding weight or by pushing up on rock and dust when it evaporates. But there remain cases that are difficult to explain. In 2011, scientists working with the Mars Reconnaissance Orbiter, a spacecraft with the most powerful camera sent to Mars yet, reported that the orbiter had spotted a curious phenomenon in Newton Crater in the southern hemisphere of Mars. Images taken several months apart showed dark streaks rolling down the crater walls and fanning out along the flatter ground below. More streaks appear as the southern spring turns to summer. Then they disappear again at winter's approach. It's tempting to think that water is the cause, darkening the soil as it runs downhill, like a wave creeping across dry sand. But the discolorations last for months, too long for liquid water to linger near the surface of Mars. Instead, water from melting ground ice may cause a chemical or physical change in the soil as it flows just below the surface. If scientists were to verify that liquid water can sometimes occur on Mars, even briefly, the implications are enormous, because that water might be all that's needed to sustain hidden colonies of Martian microbes. It's an incredible idea, one that could put an alien form of life within our grasp. But even as we imagine building more sophisticated machines that will further the quest for water on Mars, another kind of spacecraft has transformed the search for water in the universe by taking it to the stars. If there is one idea about the universe that is fundamental to all others, it's that no one place in the cosmos is truly unique. In every direction in space, there are atoms, stars, and galaxies. Just as there are here, and they obey the same laws of nature. this is an extremely profound thought, because it means that if life is possible here, we should also expect to find life elsewhere, wherever conditions are right. Conditions that include liquid water. Fortunately, space travel has given us a new set of tools for exploring beyond the solar system. They are orbiting telescopes that are making it possible to find planets around other stars. And they can even tell us if some of those planets show signs of having water. One such planet, designated HD 209458b, has been found circling a star similar to our Sun. Located 150 light-years away in the constellation Pegasus, it is the first planet outside our solar system to be observed crossing directly in front of the star that it orbits. Even though the planet is too faint to be seen directly, each time it does this, astronomers can measure how much the star's light dims and for how long. This has allowed them to calculate the planet's size and its distance from the star. But it can also reveal much more. As some of the star's light passes through the planet's atmosphere, it can be used to read the chemical signatures of the gases that are present there. Space telescopes have detected the signs of an extensive atmosphere around the planet, and they paint a portrait of a world that is unlike any in our own solar system. Heated by the relentless glare of a stellar inferno, the atmosphere of the planet has expanded, forming a long tail of gas escaping into space. Closer in, the atmosphere is subject to 1,000-degree temperatures and violent winds. At such extreme conditions, and lacking a solid surface, this planet is not expected to harbor life. But in analyzing its atmosphere, astronomers in 2007 made an important discovery. For the first time, they reported evidence for water vapor on a planet orbiting another star. This is exciting, if not a complete surprise. After all, water is one of the most common molecules in the universe. But seeing its signature in the atmosphere of so alien a world means that, in principle, water may also be detected on other planets that are far more similar to our own. The job of finding those planets falls to a highly specialized space telescope. This is Kepler. It is the first telescope with a reasonable chance of detecting another Earth. Kepler does this by staring continuously at a single patch of our Milky Way galaxy. By doing so, it can monitor over 100,000 stars at the same time. Every so often, one of those stars will dim for a few hours and then return to normal. If the dimming repeats at regular intervals, then astronomers know that Kepler has found a planet. One of Kepler's most exciting discoveries to date is a planet around a Sun-like star simply called Kepler 22b. Kepler 22b orbits at about the same distance Earth orbits the Sun. Just the right distance for liquid water to exist, and possibly life. But Kepler 22b is also not like Earth. Instead, it is nearly 2.5 times the size of our planet. Astronomers call such a world a super-Earth. Kepler 22b could be made entirely of rock, or it could be a planet-wide ocean, a water world. Another example is Gliese 1214b, a world that circles a small red star only 40 light-years from our solar system. This planet is similar in size to Kepler 22b, but much closer to its star. This makes it easier to measure the planet's mass because of the gravitational pull it exerts on the star as it orbits. From observations of the star, astronomers can tell that the planet is not nearly massive enough to be made entirely of rock. Therefore, it is either a small rocky world with a vast atmosphere or a true water world. If this is confirmed, then the notion of a planet made almost entirely of water will no longer be science fiction. It will instead be one of our nearest neighbors.
When we search for water in our solar system and beyond, what we have found is the universe's remarkable capacity to surprise us. Instead of places that resemble Earth, we've discovered Martian gullies, geyser-spraying moons, and possibly ocean planets.
What all of these findings point to is the incredible variety of environments in which liquid water can exist across the cosmos. On Earth, almost everywhere we find liquid water, we find life. If our world is any indication of conditions elsewhere, then ours is a universe teeming with life. To the eye, the universe is a domain of stars and galaxies, a dazzling pageant of matter and light. But at a deeper level, the universe is governed by unseen forces that rule the fate of every star, planet, and particle of matter that space contains. Among these forces, the force of gravity plays a unique role. Only gravity operates on everything with mass, regardless of its distance, creating a mutual attraction between all the matter in the universe.
From Newton to Einstein, the nature of gravity has preoccupied some of the greatest minds of all time. But beyond sheer fascination, there's another reason why scientists pay attention to gravity. These days, gravity isn't just a force, it's a tool that is allowing us to explore the universe and is showing us what telescopes cannot.
Our gravitational exploration of the cosmos begins close to home. Made up of nearly 6 billion trillion tons of rock and metal, our own planet, Earth, has by far the largest mass and the strongest gravity that humans have ever experienced. In fact, Earth's gravity is strong enough to hold almost anything to its surface, including soil, water, and the very air we breathe. Even the moon, a sister world hundreds of thousands of kilometers away, is held in orbit by Earth's powerful gravitational pull. But Earth's gravity is not uniform. At different points and at different times, it can be slightly stronger or slightly weaker. For scientists, these tiny differences can reveal important information about the layers of rock that lie below Earth's surface, or about the movement of water and ice at the poles and around the globe, all of which have mass and contribute to Earth's overall gravitational pull. And the best way to measure these differences is not from Earth, but from space. This is the Gravity Recovery and Climate Experiment, or GRACE for short. Launched in March of 2002, it's a joint effort by NASA and the German Space Agency to map the subtle variations in Earth's gravitational field 1,000 times more accurately than ever before. GRACE is made up of 2 satellites, which orbit Earth in tandem and communicate with each other using a microwave ranging system. Flying about 220 kilometers apart, they make an exquisitely sensitive gravity meter. Whenever the leading spacecraft passes over a part of Earth where the gravity is a bit stronger, it feels a slight pull, causing it to accelerate and increasing the separation between the 2 spacecraft. Whenever the gravity is a bit weaker, the reverse happens, and the 2 orbiting spacecraft move slightly closer together. By repeatedly measuring these slight changes, GRACE has built up a detailed profile of Earth's gravity and revealed subtle variations across the planet's surface. Here, red represents areas where the gravity is slightly stronger. These correspond to mountain ranges and other large accumulations of mass. Blue shows where there is less mass, and the surface gravity is slightly weaker. Looking elsewhere, GRACE can also record changes that show more directly humanity's growing impact on the planet. In this view of India, red represents a decrease in gravity where groundwater has been drastically depleted by human consumption over the past decade. The quest to measure Earth's gravity with ever greater precision has become a key way to study our planet's hidden structure and monitor its ongoing transformation. But as fruitful as this technology has been, scientists have also come to realize that there are many more places besides Earth where gravity can be an aid to exploration. Now, similar missions are envisioned for other worlds, where we have far less information about what goes on below the surface. The first of these is already underway, and as expected, gravity is providing an exciting new way of seeing what was once hidden. For centuries, astronomers have wondered about the invisible mechanism that seems to keep the moon circling around us with clock-like regularity. It was Isaac Newton who solved the riddle. He was the first to recognize that the same force that causes an apple to fall from a tree is the one that keeps the moon in orbit around the Earth. He not only discovered the law of gravity, he understood it was universal.
5, 4, 3, 2, 1, 0.
More than 300 years later, Newton's mathematical description of gravity is still used to calculate the flight paths of spacecraft that leave the Earth far behind, including those that set out for the moon. In September of 2011, NASA launched not one, but 2 identical spacecraft both heading for a lunar rendezvous. This is the Grail mission. Its objective, to use gravity to unlock some of the moon's deepest secrets. Like the Grace mission around Earth, Grail is designed to monitor changes in the separation between two spacecraft as they are pulled in different ways by the gravity of the body they orbit. But compared to Earth, the Moon is an even better subject for this double-barreled style of mission. The most important difference is that, unlike Earth, the Moon has no atmosphere. This means the two Grail satellites can orbit much closer to the Moon's surface and, in doing so, make a much more accurate gravity map. At the beginning of 2012, when the two orbiters arrived, they were in highly elliptical orbits that took them more than 8,000 kilometers from the Moon's surface, too far for useful measurements. But over the next 8 weeks, those orbits were carefully adjusted into tight circles with an average altitude of just 55 kilometers above the surface. At that height, the two spacecraft were tearing around the Moon at 5,000 kilometers per hour, completing one orbit in just under 2 hours. And like a high-definition movie in Fast Forward, the stark lunar landscape rushed by beneath them. Scientists nicknamed the twin Grail satellites Ebb and Flow because of the shifting nature of the measurements they were designed to make. With Flow in the lead and Ebb about 100 kilometers behind, they circled the Moon in formation so that if one felt a slightly stronger gravitational pull from one part of the Moon, the distance between the two orbiters would change slightly. The probes kept track of their relative positions by sending pulses of microwave energy back and forth while maintaining radio contact with Earth. Accurate clocks on board each spacecraft carefully tracked the timing of the microwave pulses, allowing the system to detect a change in the twin orbiters' separation as small as 1/10 of a micron, or roughly half the thickness of a human hair. With this remarkable precision, Grail set out to explore the Moon's gravity with 100 times the resolution of any previous mission. 1,000 times for the Moon's less explored far side. In this view, the best ever of the far side, the side that always faces away from Earth, we see a rough and mountainous terrain packed with ancient craters. This is entirely different from the Moon's near side, which includes large circular basins formed by asteroid impacts. Those basins are obvious on the near side because they are places where darker colored lava from the Moon's interior broke through and flooded the surface. But the far side crust is much thicker, which apparently prevented lava from reaching the surface. With its careful measurements of the Moon's gravity, Grail can see deeper into the lunar interior and help shed light on why the Moon's crust is so lopsided. It may even shed light on a surprising theory based on computer simulations that suggests the Moon's thicker far side crust was created in a collision with a second smaller moon. This epic crash would have splattered material all over the far side, like a giant bug hitting a windshield. But there are also deeper questions to answer, including whether the Moon has now lost all of its internal heat, or whether deep down it still harbors a small molten core. To probe the moon to such depth requires data from all angles. It takes the moon 1 month to rotate slowly on its axis. So after 3 months of orbiting the moon from pole to pole, Grail gathered enough data to map the moon's entire gravitational field in exquisite detail 3 times over.
Scientists are now continuing to analyze the treasure trove of data that Grail has provided, hoping for a definitive glimpse of the moon's mysterious heart. This is the promise of gravity as a tool for space exploration. It offers a way for us not just to see other worlds, but to feel what's happening inside them.
Not even Isaac Newton could have dreamed of such power. A power that can also help us reach beyond the solar system and explore the cosmos in an entirely new way. For more than half a century, conquering space meant conquering gravity. Gravity was the obstacle that had to be overcome in order to leave our planet behind and travel to the moon and beyond. But even then, scientists knew there was another way to think about gravity, not as a barrier, but as a messenger that can carry information from the distant universe. This idea comes from Albert Einstein. Unlike Newton, who thought of gravity as a force between objects, like an invisible bond, Einstein reimagined gravity as a curve or warp in space. The warp is created by matter, and it also dictates how matter moves. Take Earth, for example. Because it contains a lot of matter, Earth stretches and bends the space around it, forming a kind of dimple in 3 dimensions. As the moon moves, it's guided by the way the space around Earth is curved. Instead of traveling in a straight line, the moon's path follows the curve and keeps circling around us. But this elegant way of thinking about gravity also has an interesting side effect. If space can stretch and bend, then space can also ripple, like a wave, a gravitational wave. According to Einstein, space is full of gravitational waves, like ripples on a pond, created whenever something with mass accelerates. But in practice, these waves are so slight that we don't notice them in everyday life, and we have no means of measuring them as they propagate through space. That is, unless the situation is extreme. And in our universe, there is no situation more extreme than that of a black hole. A black hole is an object with gravity so strong that not even light can escape. Yet even though black holes give off no light, their effect on the space around them can be strong enough to generate gravitational waves. The key is looking for places where black holes are accelerating through space and making big ripples as they go. One such place could be the center of a massive galaxy. It's now thought that most galaxies have giant black holes in their cores. Such a black hole may start small, but as it is fed by the galaxy that surrounds it, it can grow to the mass of 1 billion suns. Many of the largest and brightest galaxies in the universe are thought to have originally formed out of the collisions and mergers of smaller galaxies. If so, such galaxies could host not one, but 2 giant black holes locked in tight orbits around each other. Because those orbits will eventually lose energy and decay, the black holes are locked in a death spiral, destined to collide. Drawn in by their mutual attraction, the 2 giants whip around each other at high speed. As they do, they generate massive ripples in space. Traveling outward, those waves will eventually sweep through our solar system, carrying information that could help scientists better understand the origin and development of giant black holes and their role in the history of the universe. But how to detect them? The answer is simply to measure space. Scientists have now begun to develop a measuring tool that will use lasers to detect minute changes in length across different distances in space. It's called LISA, the Laser Interferometer Space Antenna. LISA will consist of 3 spacecraft precisely spaced in a triangle that is 5 million kilometers to a side. Using laser beams to track their relative positions, they can detect a change in their separation down to 5 trillionths of a centimeter. Such extraordinary precision lies at the very limits of current technology. But it should be just enough to allow scientists to listen in on a universe that is filled with gravitational waves. What will it be like to perceive such a universe? Most of the time, scientists expect it will be like listening to a continuous buzz made up of waves from millions of black hole pairs located in galaxies scattered in every direction. But every now and then, there should be a much larger boom of gravitational waves created whenever 2 black holes finally collide and merge. It's beyond the ability of even the world's most powerful telescopes to witness such an extreme and violent event. But LISA could give us a front row seat.
Gravitational wave astronomy is so new that in a sense it hasn't even been born. That won't happen until a gravitational wave detector picks up its first real signal. But many researchers expect that moment is coming soon and that our generation will be the first to tune in to a whole new way of perceiving the universe.
As we do, we will again come face to face with a remarkable truth about our universe. Though it often appears vast and incomprehensible to the human mind, contained within its awesome beauty are the clues that will help us understand what makes the universe the way it is. A place where creatures like us can exist and explore. traveling for hundreds of thousands of miles per day, yet always in sight of home. The product of a bold past, but also the bridge to an ambitious future. Designed to make spaceflight routine, it has taught us our most painful lessons about the danger that lurks whenever humans journey beyond our home planet. This is the legacy of the Space Shuttle, a vehicle that for over 3 decades came to define human spaceflight, while helping to create a permanent presence in orbit. But for scientists, the fleet of space shuttles also meant something more. They were traveling laboratories with access to the unique environment and perspective of low Earth orbit. Impossible to reproduce on the ground, this was to be the setting where astronaut researchers would test the limits of materials, the universe, and even their own bodies. All essential information that could one day help humans venture much farther into deep space. Of the 5 shuttles that blasted off from Cape Canaveral, only 3 remained. But despite the tragic loss of Challenger and Columbia, the program successfully completed 133 missions. And nearly 150 astronauts have flown in a shuttle, many of them making several trips.
The Space Shuttle may have completed its final journey, but over 30 years, it's managed to transform spaceflight by making it just a bit more routine, even as it's taught us that extreme exploration still comes with tremendous risks. The shuttle has also blazed a trail for science in space, a trail that continues aboard the International Space Station.
Today, the idea of a continuous presence in space in support of scientific research is no longer a dream. But it took the shuttle program to get there, and that took an act of true vision. In 1969, the same year that Neil Armstrong first walked on the moon, a small group of engineers in the California desert had a job to do. It was to build a vehicle to ferry people back and forth to low Earth orbit. Known as STS for Space Transportation System, this new kind of spaceship wasn't going nearly as far. And to be affordable, it would have to be reusable, a space plane that could survive both liftoff and re-entry. These early test models were dubbed flying bathtubs because of their clunky shapes. But what they lacked in grace, they made up for in stamina. Designed to deflect heat away from the crew cabin, the vehicle's wide underbelly was the key that would allow it to endure the searing, high-speed descent through the atmosphere over and over again. The final shuttle design included wings for stability, a feature that would allow the craft not just to descend, but to glide into a low-impact landing. The design was flight tested by releasing the shuttle from the back of a specially outfitted Boeing 747. But no flight test on Earth could reproduce the harsh environment of space. So, on April 12, 1981, the first of the shuttles to be readied for orbit sat poised on the launch pad.
6, 5, 4, we've gone for main engine start.
And as Columbia soared successfully into the sky, a 30-year journey for science on the shuttle was set to begin. With better access to space than ever before, researchers had a long list of topics they were eager to explore with NASA's new orbiter. And the first subject of serious study from the space shuttle was the one that was visible just outside the crew cabin windows: Earth. By now, views of our planet from a few hundred kilometers up were a familiar sight thanks to earlier chapters of the space program. But with bigger windows than the space capsules of the 60s and 70s, and with better technology to take advantage of that view, the shuttle raised Earth observation to a new level. This effort was already underway by the second space shuttle mission, which carried an imaging radar, a way of bouncing microwaves off of Earth's landforms to build up a detailed picture of our planet's diverse geography. The radar system proved to be a powerful tool for Earth scientists because, unlike photography from space, it worked regardless of whether it was imaging the day or the night side of the planet. It was also unaffected by cloud cover. Flying aboard the shuttle 3 times over the next 13 years, the radar system returned alluring and spectacularly colorful views of the surface. For scientists eager to study our world from above, there was no doubt the space shuttle had arrived, and it was showing them Earth like they'd never seen it before. It's said that beauty is only skin deep. But when it comes to imaging Earth from orbit, being able to see beneath the skin is a big advantage. That was the principle behind the space shuttle's imaging radar, which not only bounced microwaves off the planet's surface, but watched them penetrate a little way into the surface, allowing the system to see hidden information in the underlying rock and soil. Here, for example, a spectacular view of Mount Etna on the island of Sicily, one of the world's most active volcanoes. It reveals the complex succession of lava flows that have spilled down the mountain sides over many generations. Scientists compare images like these with what they observe on the ground and can use them to help explore more remote volcanoes from orbit. In another case, the dry, blowing sands of the Sahara Desert nearly conceal this curious geologic feature lying just below the surface. But because radar can penetrate the top layers of sand, this shuttle radar image of the Arunga crater in northern Chad shows what happened when a small asteroid collided with Earth hundreds of millions of years ago. The shuttle was used to study the possibility that the asteroid broke up into pieces before it struck, leaving not one crater, but a chain of at least 3 craters. Elsewhere, the same technology has also helped document more immediate changes. Here we see a shuttle radar view of Chile's vast and remote Patagonia ice fields, taken in October of 1994. In this view, red and purple indicate areas of high elevation. By comparing this image to one taken in the same shuttle mission, researchers were able to measure the speed at which different parts of the glacier are moving. Such measurements are crucial for understanding how Earth's icy regions are responding to global climate change.
We've gone for main engine start.
By the year 2000, the use of the space shuttle as a radar platform had evolved into the Shuttle Radar Topography Mission.
which produced high-resolution elevation data for 80% of Earth's surface. The result was, at that time, the most detailed map of our world ever made. The Space Shuttle also explored our home planet in other ways. On 3 missions between 1992 and 1994, it carried the Atlas experiment, designed to measure the chemistry of Earth's atmosphere and its interactions with the Sun. Among its many contributions were data that support the realization that chlorofluorocarbons, or CFCs, are damaging Earth's protective ozone layer, and that their production had to be curtailed. But this was just the beginning. Throughout the 1980s and 90s, the Space Shuttle offered a gateway for science in space of all kinds, especially science that could take advantage of the most obvious feature of space travel: the fact that in orbit, the concept of up and down seems to vanish. The reason things behave so differently in low Earth orbit is also what makes it difficult for humans to work there: microgravity. As the shuttle orbits, it's actually falling around the Earth. Everything in it is falling too. Earth's gravity is still there, but its effects are no longer felt. This microgravity environment affects every aspect of spaceflight, from the design of the toilets to the way we might expect to grow plants for food in the future. Without gravity as a guide, plants have no sense of down. Roots sometimes grow in the same direction as leaves. The effects of microgravity extend even to the smallest scales. In one startling shuttle experiment, salmonella bacteria were shown to become more active in space. Working with the space bacteria, scientists were able to identify the gene that switches on this behavior, a possible step toward developing a protective vaccine against salmonella, one of the most common causes of food poisoning. But humans are also not immune to the effects of spaceflight. In perpetual freefall, the gravitational cues that the body relies on for everything from muscle development to circulation to perception are gone. And while the sensation of flying in space can be liberating, at the physiological level, microgravity presents a severe challenge to the human body. One of many that must be surmounted before humans can live permanently in space. The Space Shuttle has been crucial to building up our understanding of what happens to the body when it's in space. But perhaps most important of all, starting in the late 1990s, the Space Shuttle became the essential tool for creating the International Space Station. A more ambitious and longer-lasting presence in space, and a stepping stone into the future. And with human spaceflight reaching for new heights, so too were the scientists eager to make use of the new facility to extend human knowledge into new frontiers. From the moment the first space shuttle took flight, humanity was on a new path. One that made low Earth orbit a familiar destination for an entire generation of astronauts. But the shuttle was, first and foremost, a vehicle, not a port. Even the longest shuttle missions were rarely over 2 weeks. To realize the full scientific potential of low Earth orbit for many types of experiments, researchers needed a permanent laboratory rather than an occasional visit. So, to establish a new outpost in space for a new century, NASA, the US Space Agency, teamed up with Russia, Europe, Japan, and Canada to create the International Space Station, one of the boldest construction projects in history. Of course, the shuttle would play a key role in building the station. Starting in 1998, it began ferrying up many of the modules and other elements needed for the giant habitat. In combination with the pieces lofted up by Russian Proton and Soyuz rockets, the massive station gradually began to take shape, reaching its completion only with the final few shuttle flights some 13 years later. During those years, the space shuttle became less available to scientists eager to pursue experiments in orbit. But the end result is something far grander and more versatile. By November of 2000, long before the station was completed, astronauts began arriving for the first long-duration missions to the station. The station has been occupied ever since, setting a new record for continuous human presence in space. In its current form, the space station accommodates 6 astronauts, giving researchers an unprecedented platform from which to conduct experiments in life sciences, materials science, earth science, and astronomy. And with a construction cost nearing $100 billion, NASA and the other partners behind the station are eager to get the most benefit possible out of the facility. In May of 2011, during what would be the second last space shuttle mission, astronauts delivered a final piece of scientific apparatus to the station. An unusual detector designed to probe some of the most powerful and mysterious energy sources in the universe. It's called the Alpha Magnetic Spectrometer 2, a device that counts and measures the high-speed particles coming from all directions in space, known as cosmic rays. It's thought the most powerful cosmic rays are generated by supernova explosions and giant black holes. But some may point to even more exotic processes at work in the cosmos. The trick is seeing enough of them to spot the types of cosmic rays that are truly rare. The vast majority of these particles are ordinary cosmic rays that are already well understood by scientists. But it's also possible that a very few of them will carry hints of an exciting discovery, possibly revealing whether other parts of the universe are made of antimatter, or else helping to identify the nature of the dark matter that astronomers suspect is everywhere around us, but completely invisible to ordinary telescopes.
In more practical terms, the AMS-2 will give scientists their best information yet about the high-energy particle environment in our solar system. This knowledge is crucial for understanding how astronauts may one day avoid the hard radiation exposure that is one of the main hazards of a long interplanetary voyage.
Having fired the imagination of a generation, its place in history secured, the space shuttle pulls into port for the last time.
Following the final flight of the space shuttle in July of 2011, a new chapter was opened for the International Space Station. One in which private spacecraft, like the Dragon capsule built by SpaceX, take up some of the work of bringing supplies to the station.
With private companies servicing the space station, the hope is that NASA can move on to more challenging destinations, like taking humans back to the moon, or the asteroids, or Mars. Meanwhile, the International Space Station will continue to provide a platform for science in space. Some wonder if the station has been worth all of the trouble and expense to build, but its true legacy may be in setting the stage for a longer-term human presence in the solar system.
Oh, this is fantastic. Looks nice. Nice.
Stark desolation or breathtaking beauty. The planet Mars offers both at once, and much more. No other world has so captivated human imagination, and apart from Earth, no other planet has been more closely examined or studied. Yet Mars continues to defy our expectations. And the closer we look, the more we realize we barely know Mars at all.
The act of exploring another world is a plunge into the unknown. But Mars is different. So many spacecraft have been sent there that by now, its major features are as familiar to scientists as the continents of the Earth. Today, the real unknowns on Mars are found at a smaller scale, a human scale, and exploring them takes a keen eye for detail.
Today, there's no keener eye on Mars than the one that belongs to MRO, the Mars Reconnaissance Orbiter. Like a great bird scanning for prey, MRO soars over Mars with its solar panels outstretched, using the most powerful camera ever sent to another world to peer down at the alien terrain passing below. As it orbits from pole to pole, MRO scans the surface, creating images in long strips that are only a few kilometers wide, but could stretch to well over 100 kilometers long. Within these narrow strips, MRO's sensitive camera can perceive features as small as a dinner plate. That's many times sharper than any previous spacecraft has ever seen Mars from orbit. And it means that MRO is the first orbiter with the power to connect the Mars we see from space with the Mars we wish to explore on the surface. Painted in false color images that are chosen to bring out interesting features, MRO's views of Mars are views at the level of local geography. But taken together, the small-scale details they reveal help to tell a very big story, both about the planet's current conditions and the ancient processes that produced this astonishing landscape. And because those processes involved heat and water, it is also possible that billions of years ago, they enabled the emergence of life on Mars. If life once did gain a foothold here, the evidence is buried under layers of Martian rock, layers that MRO can discern better than any other orbiting spacecraft. In fact, MRO has turned Mars into a planet of layers, allowing scientists to explore Martian history as though it were the skin of a giant onion. MRO has also shown Mars to be a planet sculpted by wind, where fine-grained dust can form vast fields of dunes that gradually migrate across the planet. The dunes of Mars are spectacular, rippled masterpieces that remind us of nature's power to create and destroy entire landscapes one sand grain at a time. With their shifting, sinuous features, the dunes bring Mars to life, revealing the dynamic nature of its surface. But the wind can also create phenomena that are much more fleeting. In many regions of Mars, MRO has found dark streaks crossing the plains, like scribble marks from a giant pen. These are the tracks left by dust devils, wispy whirlwinds that traipse across the surface like miniature tornadoes, scouring the rock clean of dust as they go. Dust devils are so common on Mars that MRO has captured several of them. Here, one twists serpent-like above the plane, casting a long shadow that reveals the dust devil is nearly a kilometer high. Elsewhere, there is a different kind of evidence that Mars can be the scene of dramatic action. Here, the spacecraft examines a crater that was not present in a 2009 photo, but appeared in 2011. In false color, the freshly excavated debris of the blast looks bright blue against the dusky surface. These fresh impacts are not just curiosities. The material they expose provides clues to what lies just below the Martian surface. And sometimes they can even expose a hidden layer of ice, the frozen remains of Mars's warmer, watery past. MRO has also seen plenty of ice sitting on the surface of Mars, but this is dry ice, made up of frozen carbon dioxide rather than frozen water. As it comes and goes with the seasons, the dry ice can take on a fascinating diversity of forms, sometimes appearing as though painted on the Martian surface by an artist with a flair for the improbable. And sometimes the view of a Martian polar terrain covered with dry ice can even seem to resemble bacteria under a powerful microscope. So powerful is the eagle eye of MRO that it has even been used as a telescope to look up at the two moons of Mars, Phobos and Deimos, as they orbit high overhead. These moons may someday serve as outposts, where human astronauts arrive before descending to explore interesting sights on the planet below. By then, the surface of Mars will have been scouted and sampled by a new generation of robot explorers. And those robots will be looking to MRO to tell them where to land. On the smooth slopes of Pavonis Mons, a giant Martian volcano, the Mars Reconnaissance Orbiter makes a startling discovery. A small crater, alone on the featureless landscape, appears to have a strangely dark center. Looking more closely, MRO finds that what seems like a crater is really a natural skylight, where part of a volcanic formation has collapsed, exposing a hidden cave below. This remarkable picture invites the tantalizing prospect of someday entering the cave and exploring Mars beneath the surface. But falling into such a hole unexpectedly would spell disaster for a rover on Mars. And that's why orbiting missions are used to spot both the hazards and the opportunities on the red planet.
When it comes to Mars, every orbiting spacecraft has two jobs. The first is to explore the entire planet from above, gathering the clues that researchers need to put together the story of the red planet on a global scale. The second job is to pave the way for exploration on the surface of Mars by finding the perfect place to land.
With its high-powered view of the surface, MRO has played a key role in the planning of missions to land on Mars, offering more information about potential landing sites than once was ever thought possible. In the history of Mars exploration, this is still a recent development. In fact, two of the best-known Mars explorers, NASA's Spirit and Opportunity rovers, had already been working on the surface for years before MRO arrived. Amazingly, MRO's vision is sharp enough to spot the rovers on the surface, although each is not much larger than a wheelbarrow. Here, the orbiter zooms in on the rover Spirit, which gleams brightly as sunlight reflects off its solar panels. Meanwhile, over on the other side of Mars, MRO finds Opportunity perched on the rim of Endeavour crater. With a diameter of 22 kilometers, this is the largest feature Opportunity has explored to date. It headed this way after MRO saw evidence for minerals related to water in its orbital view of the crater. Soon after MRO reached Mars in 2006, it had its first assignment helping a surface mission find the best landing site. The mission was Phoenix, a lander designed to touch down in the north polar regions of Mars and probe for the permafrost believed to lie just below the surface. Prior to MRO's arrival, mission planners favored an area known as Region B for Phoenix's landing site. But with their improved view from MRO, they found that Region B was full of boulders that would have spelled disaster had the lander set down on one. Instead, a backup landing site was chosen, and Phoenix landed safely in May of 2008. Soon after, MRO was able to confirm the lander's position by imaging it from space. For the first time in history, a landing on Mars had come with its own eyewitness. The next mission to Mars was to be much more complicated. Instead of a lander, NASA had decided to send another rover to follow up on Spirit and Opportunity's impressive finds. This newer and much larger rover was to be the most sophisticated probe ever to set down on Mars, an entire mobile laboratory. And it might be the first to determine if Mars once had conditions suitable for life. And with only one rover to land, there would be no second chances. MRO set about scouring the planet, helping pinpoint geologically interesting locations. As with earlier missions, high priority was given to places where there is evidence for past water flowing on the surface of Mars. Starting with a list of more than 60 candidate landing sites, scientists began a detailed 5-year investigation to find the best possible location for the next rover on Mars. Using data from all available orbiter missions, but relying especially on detailed views from MRO, scientists managed to narrow the list to 4 finalist sites by the spring of 2011. Among them were some of the most intriguing and geologically complex places on Mars. Places such as Holden Crater, an ancient formation that was turned into a vast lake when a channel carrying floodwaters breached the crater rim. Just north of Holden is another candidate site, Eberswald Crater. It also shows signs of past flooding, but here the key feature is an ancient river delta at one end of the crater. A very different kind of landing site presents itself at Mars Vallis. Billions of years ago, this channel drained a torrent of water from the Martian highlands in the south to the low-lying northern plains. All 3 of these sites show terrific potential for uncovering the history of water on Mars. But in the end, scientists chose a 4th site, a site that combines some of the most attractive features of all the others in one location, and adds a mysterious mountain that could unlock the secrets of ancient Mars. After more than 40 years of interplanetary exploration, Mars has offered some of the most spectacular sights in the solar system, from huge volcanoes to deep chasms to the beautifully sculpted layers of ice and dust that cover the Martian poles. But among its many diverse and intriguing features, there is nothing on Mars that looks quite like this: a giant mound more than half the height of Mount Everest, sitting squarely in the middle of an ancient impact crater. This is Gale Crater, a formation that has long attracted interest and speculation from Mars scientists. It's also the landing site of the most ambitious mission ever to touch down on the Red Planet, NASA's Mars Science Laboratory, better known as the Curiosity rover. Compared to previous rovers, Curiosity is built like a tank. The size of a small car, it weighs 900 kilos and carries 10 separate scientific instruments for the detailed testing of the rocks, soil, and atmosphere of Mars. But most importantly, Curiosity is powered by a device that generates electricity from the radioactive decay of plutonium. Curiosity's nuclear power supply would give it the potential to explore Mars for years, allowing scientists to select a more ambitious target. and few features on Mars are as scientifically interesting as the mountain in Gale Crater. Nicknamed Mount Sharp after a pioneering planetary scientist, this strange formation rises above everything else around it, including the rim of Gale Crater. Closer inspection by the Mars Reconnaissance Orbiter has revealed that the mountain is really a pancake stack of sediment, whose lowest sections are made of clay layers that formed in the presence of water. Those layers could well be a gold mine for scientists because they represent a slice of geologic time that spans over 100 million years of the most crucial period in Martian history. A time when Mars may have shifted from a habitable planet to a frozen desert. By July of 2011, Curiosity's fate was sealed. NASA announced that their new rover was destined to become a mountain climber.
3, 2,
The rover would be sent to Gale Crater.
and liftoff.
Now, it just had to get there in one piece. After years of planning and an 8-month journey from Earth, the moment of truth arrived on the night of August 5th, 2012. Nested safely in its protective capsule, Curiosity jettisoned its cruise stage and, drawn by the planet's gravity, began its terrifying plunge. Soon, friction with the thin Martian atmosphere began heating up the front of the capsule to a peak temperature of over 2,000 degrees Celsius. Now, still traveling at over 1,400 kilometers per hour and just 11 kilometers from the surface, Curiosity deployed its parachute. 15 seconds later, the heat shield fell away, revealing the rover tucked inside. But now, the rover was still falling fast when it separated from its parachute and back shell and ignited 4 powerful descent rockets. But how exactly to land? Separating from its descent stage, the rover was lowered to the surface on 3 nylon cables. As it touched down, the cables were cut and the descent stage veered off, crashing to the surface a safe distance away. And then came the signal.
Curiosity is the 7th mission to land successfully on Mars, but it's different from all its predecessors in a crucial way. It is the first Mars mission to combine the mobility of a rover and the scale and complexity of a field laboratory with the potential for operating for years on the planet's surface. That combination will change our understanding of Mars forever.
This will be the longest journey ever attempted on another world, but it will not be as lonely. As Curiosity begins its epic trek across the surface, it will be watched from above by MRO, the eagle eye that has become part of day-to-day life on Mars, even as we look for signs of life in the past.